Hello and welcome to my science tutorials. In today's video, we want to look at the part 2 of the series connected impedances. Before we begin, if you're new to my science tutorials, kindly consider subscribing and turning on the notification button so that you do not miss any of our latest tutorials on biology, chemistry, mathematics, and physics. So without further ado, let's begin. Now, in our previous tutorial, we did look at how to solve problems on multiple impedances in an AC circuit. Today, we want to continue with that idea and try multiple examples to see how we can solve more questions on series connected impedances. So we have an example here. We have three impedances are connected in series across 100 volts 2000 hertz supply. The impedances comprise of I, an inductance of 0.45 millihenry and 20 ohm resistor, II, an inductance of 570 microhenry and 5 ohms resistor, III, a capacitor of capacitance 10 microfarad and resistance 3 ohms. Assuming no mutual inductive effect between the two inductances, we are to calculate A, the circuit impedance, B, the circuit current, C, the circuit phase angle, and D, the voltage across each impedance. So let's go ahead and look at how we solve this problem. So let's write down our solution. Now the first thing we need to do is to draw the circuit to have a fair idea of what we are working with. So we have three impedances in one circuit. So the I aspect is telling us we have an inductance of this. So we have an inductor, and then we have a resistor, then connected to II, another inductor, which is also connected to another resistor, and then III, we have a capacitor, which is connected to a resistor. Okay, so this is our circuit. So we have over here 0.45 millihenry, we have 20 ohms over here, then we have here 570 microhenry, then we have 5 ohm resistor here, then we have a 10 microfarad capacitor, and then 3 ohms resistor. So this side, this is our first impedance. So this is our impedance 1, or I, impedance 1. This becomes our second impedance, or impedance 2. This is impedance 2. And then this is the final impedance, or the third impedance, impedance 3. So our impedance 3. Okay, so we have our current flowing in this direction. We're told we have 100 volts and then 2k hertz supply of frequency. So let's write that well. 2 kilohertz. Okay. Alright, now the first thing we need to do is to simplify this circuit so that we can go ahead and solve the questions much more easier and faster. Now if we look at all this circuit, the impedances have some components that are common. We have an inductor here, an inductor in the second impedance. We have a resistor across them all, and then we have one capacitor. So we can simplify this circuit to have a much more simplified version, which would just have an inductor connected to a resistor, which is also connected to a capacitor, and then connected to a source of voltage. We have our current I in this direction. We have our 100 volts 2000 hertz frequency supply here. Then our resistor, the total resistance of this particular circuit will not be the sum of the first resistor in the impedance 1, the second resistor here, and then the third resistance over here. So if we look at it, we have, apologies, this is supposed to be 2 ohms, so this is 2 ohms, this is just 2 ohms, not 20. So we have 2 plus 5 plus 3, that's going to give us 10 ohms. Then we have 10 microfarad here. Then for the inductor, we have 0.45 millihenry plus 570 microhenry. So if we add these two, 0.45 times 10 raised to the power negative 3 plus 570 times 10 raised to the power negative 6 is going to give us 0.00102 Henry as our total inductance. So this is our L total, LT is equal to this. This is our total resistance, and then this is our capacitor in this particular circuit. So now that we have this, let's go ahead and look at the circuit impedance, the E, circuit impedance. Circuit impedance. Now the circuit impedance Z is given to us mathematically as the root of R squared, which in our case will be R total squared, plus into bracket, then we have inductive reactance minus capacitive reactance all squared. So this is the formula that we need to use to calculate the circuit impedance. So let's go ahead and look at how to do that. So we said that our impedance Z is equal to the root of R squared plus into bracket XL minus XC squared. But if we look at the parameters that we have over here, we realize that we know R total, but we only have LT and then C. We don't have XL and then XC. So we need to find what XL is, and then we need to find what XC is. Once we find these two, we can go ahead and substitute them into this formula to get our impedance. So what is XL? XL is the inductive reactance. So it is given mathematically as 2 pi FL. This is equal to 2 pi multiplied by the frequency, which was given to us to be 2000. So we have 2 times 10 raised to the power 3. Then multiplied by the inductance of the inductor, okay, which is the LT, L total that we saw earlier on. We said that is equal to 0.00102. So we do that, 0.00102. Now if we compute everything here into our calculator, our total inductive reactance is going to be equal to 12.82 ohms. Now the second thing we need to find is our capacitive reactance. Our capacitive reactance is given mathematically as 1 over 2 pi FC, or C total, which in our case, since we are dealing with multiple impedances, so this is equal to 1 over 2 pi. Our frequency is still the same, 2 times 10 raised to the power 3, multiplied by our C total. If we look at it, is 10 microfarad. So we have 10 times 10 raised to the power negative 6. Now if we compute everything here into our calculator, we are going to get 7.96 ohms as our answer. So we have 7.96 ohms as our answer over here. So now that we found the inductive reactance and the capacitive reactance, knowing very well that our total resistance that we found is 10 ohms over here, 10 ohms, we can go ahead and find our impedance now. So our impedance Z is equal to the root of 10 squared plus into bracket, then we have 12.82 minus 7.96 squared. Now if we compute everything here into our calculator, we are going to get a total impedance of 11.12 ohms. So this now becomes our impedance for the entire circuit. So the answer for A, impedance Z, is equal to 11.12 ohms. Now let's go ahead and look at the B aspect of this question. The B aspect says we should find the current or the circuit current. So the circuit current. Now the circuit current is very easy. In alternating current, we know that voltage, or in RLC series circuit, we know that voltage is equal to I multiplied by Z, where Z is the impedance or the total opposition to the flow of current in an RLC series circuit. Now our Z we've already found to be 11.12. Our voltage we were already given in the question, that is 100 volts. So we can go ahead and do the substitution and get our current. So our current from here will be equal to the ratio of the voltage on the impedance, and that will give us 100 for the voltage divided by 11.12. So our current in this case is equal to 100 divided by 11.12 will give us 8.99 amperes as our current. So the current in this particular example is 8.99 amperes. So let's go ahead and look at the third one, C, the circuit phase angle. C, circuit phase angle. Now to find the circuit phase angle, we use tan. The angle is equal to the ratio XL minus XC all on R total, or the total resistance in this particular circuit. So our angle will now be equal to the tan inverse of 12.82 minus 7.96 all on our R total over here in this question is 10 over here. So our angle will be equal to, if we take the tan inverse of this ratio that we have over here, we are going to get an angle of 25.92 degrees as our phase angle. So now that we have our phase angle, let's go ahead and look at the last part. So we have to find the voltage across each impedance. So D, voltage across each impedance. This implies that we need to find a voltage across impedance 1, voltage across impedance 2, and voltage across impedance 3. Now if you look at it, impedance 1 has an inductor and a resistor, impedance 2 an inductor and a resistor, impedance 3 has a capacitor and a resistor. So this means that to find the voltage of impedance 1, let me use V1, is going to be IZ1, where Z1 is equal to the impedance of, or impedance 1, the impedance, the resistance, or the total opposition to the flow of current in impedance 1. So this will be equal to our current multiplied by impedance 1. If we look at it, the components are inductor and a resistor. So our impedance Z will be equal to the root of R squared plus XL squared. Alright, so our VI or V1 will be equal to our current that we found earlier was 8.99 multiplied by the root of the resistance in this particular question over here is 2, so we have 2 squared plus XL, okay, XL over here we said is 2 pi FL, and then the inductance over here is 0.45 millihenry. So we use that. So we have 2 pi, the frequency is 20,000, sorry, 2000, that is 2 times 10 raised to the power 3 multiplied by 0.45 times 10 raised to the power minus 3 squared. So okay, let me make this in a bigger bracket so we can identify them. Okay, so we are squaring 2 pi f, which is the frequency, and then L, which is the inductance. This over here is the formula for XL. So this is XL squared, and then the root sign is affecting it all. Okay, all right, so if we do the computation, everything over here will be equal to 8.99 multiplied by the root of 2 squared plus 2 pi fl squared will give us 5.998, and then if we multiply that, that is going to give us 53.92 volts. So this is the voltage across the first impedance. Now let's look at the voltage across the second impedance. So let me get some space here so that we continue. All right, so the voltage across the second impedance, let me use it, V2, will be IZ2. Then this will be equal to I, which is the current, the Z over here, which is our impedance. If we look at the second impedance, we have an inductor and a resistor just like the first one. So the formula is going to be the same. We'll have the root of R squared plus XL squared. Now our current is the same, so we have 8.99 multiplied by the root of our resistance. In this case is 5 ohms, so we have 5 squared plus our inductive reactance over here is going to be 2 pi f, the frequency, which is 2 times 10 raised to the power 3. Our L inductance over here is equal to 570 microhenry, so it's 570 times 10 raised to the power negative 6, and then all this in a big bracket squared. Don't forget to square it because 2 pi fl is that of the inductive reactance XL over here, so we need to square it. Okay, now this will give me, I still have my 8.99 over here. If I multiply everything I have over here in the root sign and I apply the root sign to it, it's going to give me 8.735. So 8.99 multiplied by 8.735 will give me a total of 78.53 volts. So this is the voltage across the second impedance. So let's do the same thing. The voltage across the third impedance will be IZ3, and then our I is still the same, but our Z3 will be equal to the root of R squared, since we have resistor in over here, but this time around we have a capacitor instead of an inductor, so here will be equal to XC squared. Okay, this is too long, so we'll have our I, okay, which is 8.99. let me just write it straight, 8.99, then into bracket the root of 3 squared, which is our resistance, plus over here our XC, just the XC, is 1 over 2 pi f, which is the frequency, which is 2 times 10 raised to the power 3. Then our capacitance of the capacitor, which is 10 microfarad, so we have 10 times 10 raised to the power minus 6. Okay, this is under the bracket, sorry, under the root sign over here. That is just for XC. So we now have to square everything here whilst it's still under the root sign over here. All right, so we have 8.99 into bracket the root of 3 squared plus 1 over 2 pi multiplied by the frequency multiplied by this will give me 7.96. So I now square it. Then if I multiply everything over here, I'm going to get 76.47 volts as my V3, or the voltage across the third impedance. Now let's have a look at another question to further enhance our understanding of series connected impedances. So example number 2, a very short, quick and easy one. So we have example number 2. For the circuit shown in the figure below, we are to determine the voltages V1 and V2 if the supply frequency is 1 kilohertz. We are also to determine the voltage supply and then the circuit phase angle. Alright, so we're told to find V1 and V2, find the total voltage and then the phase angle. This is very easy. So let's go ahead and look at what we have. So we have a circuit that has impedance 1 and impedance 2, so Z1 and Z2. Impedance 1 has 5 ohm resistor and then a 1.91 millihenry inductor. Impedance 2 has a 10 ohm resistor and then 4.974 microfarad capacitor. Okay, we're told that the total voltage we don't know, but the frequency is 1000 hertz over here. All right, so let's go ahead and look at what we can do. We also have a current which is 2 amperes over here. So let's go ahead and see what we can do. Now the first thing we always do is to try to simplify the circuit so that we can go ahead and do our calculations. So in simplifying this circuit, we are going to have just one resistor, one inductor, and then one capacitor connected to an AC source. So we don't know the voltage, but we know we have a 1 kilohertz frequency supply. We're also told that our current is 2 amperes, which is very generous of them. If we add 5 and 10, our total resistance over here will be 15 ohms. Our inductor is going to be the same, 1.91 millihenry, and then we are going to have 4.974 microfarad as our capacitor over here. Okay, so if we look at this is now very simple and then very easy for us to use. Alright, so the first thing we want to do is to find the impedance, okay, of this entire circuit. So to find that, we know that our impedance Z is equal to the root of R squared plus into bracket XC minus XL squared. This is the formula. Now if we look at it, we don't have XC, we don't have XL, so we can use this formula yet. So we need to find XC, we need to find XL. This is now quite following the same trend. So our XC we said is 1 over 2 pi FC, and that is equal to 1 over 2 pi. Our frequency is 1000, so 1 times 10 raised to the power 3, then multiplied by our capacitor. Okay, the capacitance of the capacitor here is 4.974 times 10 raised to the power minus 6. All right, so if we compute everything we have over here into our calculator, we are going to get a total of 31.997 ohms for our XC, or our capacitive reactance. Now for our inductive reactance, is the formula is, let me write it a little bit down, so let me cancel this. XL is equal to 2 pi FL, and that will be equal to 2 pi multiplied by the frequency. Our frequency over here is still 1000, so 10 to the power 3, then multiplied by our inductor over here is 1.91 times 10 raised to the power 3. Okay, so if we multiply everything that we have over here, we are going to get a value of 12 ohms as our inductive reactance. Alright, so now that we have the capacitive reactance, now that we have the inductive reactance, let's go ahead and do the substitution to find our impedance. So our impedance Z will now be equal to the root of our total resistance is 15, so we have 15 squared plus into bracket XC, which is bigger, so it's 31.997 minus 12 all squared. Okay, so if we compute this into the calculator, our Z, which is our impedance, will be equal to everything we have over here. If we apply the root sign to it, we are going to get 24.9976, which is approximately equal to 25. So we have 24.9976, which you can approximate to 25 ohms. So the total opposition to the flow of current in this circuit is 25 ohms. Now that we have the 25 ohms as our impedance, we can go ahead and find the voltage supply. So let's do that. So our voltage supply, V, will be equal to IZ. Now I was given to us in the question as 2, and then we just found our Z impedance to be equal to 25 ohms. So it means if we multiply 2 by 25, we are going to get 50 volts, and so our supply voltage is equal to 50 volts. Alright, let's go back to the question. We're also to find the phase angle V1 and then V2. So let's look at that. So before we find V1 and V2, let's look at the phase angle. So the phase angle will be tan phase angle is equal to XC minus XL, all divided by, right, so let me, if I see, we have XC minus XL all divided by our total resistance R. So this will be equal to, the angle is now the tan inverse of the ratio. If we look at it, we have our XC is 31.997, so we have 31.997 minus our XL is 12, so we have 12 here, all divided by 15. Now tan inverse of this ratio is going to give us, our angle now will now be equal to 59.03 degrees. Alright, so now that we have our voltage supply, now that we have our angle, let's find V1 and V2. Okay, so if we go back to the diagram, V1 has a resistor and then an inductor, so it means our V1 will be current multiplied by Z1, which is equal to current multiplied by into bracket the impedance Z1 here will be R squared plus XL squared, since we have inductor in here. So that will be equal to our current, we're told, is 2, then our resistance is 5 over here, so we have 5 squared, plus our XL, since we only have one inductor in this question, our XL over here is the same as this guy, so it's 12, so we have 12 squared. So if we do the multiplication over here, everything over here is going to give us a total of 26 volts. So this is our V1. Our V2 will also be the same, so we have IZ2, which is equal to I multiplied by the root of R squared plus XC squared. XC in the sense that V2 has a resistor and capacitor, so R squared plus XC squared. So this is equal to, our current is 2 multiplied by the root of our resistance in that particular circuit is 10, as we can see over here, so we have 10 squared plus our XC. Since we only have one capacitor, this XC is equal to the X that we found over here, so it's 31.997, or let's just make it 32, so that is 32 squared over here. So if we calculate everything that we have over here, we will have 67.05 volts as our second voltage supply. So thank you so much for watching. I hope you enjoyed this tutorial, and this video helps further enhance your understanding on series connected impedances. So thank you once again for watching, and I will see you in the next video. Bye bye.